afternoon. I am Dr. R Pandeeswari, Assistant Professor in Department of Physics. So today I am going to take the topic of cathode ray and anode rays. So before going for this topic, we should understand the what is the atoms. So in general, in this world, it's all the things are made up of atoms. So finally, it is end up with atoms. So atom, we have a different types of atom models are there. Dalton model, J.J. Thomson model, quantum mechanical model, vector atom model, Sommerfeld atom model, like that we have a variety of atom models. In any single atom, it contains proton, neutron and electron. In center part, we are called as a nucleus. It contains the proton and neutron, and electrons are revolving around that nucleus. So these are the basic elementary particles which is present in any one single atom. So we are mainly in this presentation, we are mainly focused for the electron and proton. So because based on that elementary particles, we are getting this cathode ray and anode rays. So cathode rays, which is nothing but the beam of electrons which is traveling from the negatively charged cathode to the positively charged anode, and that is this cathode rays are first discovered in J.J. Thomson in the year of 1897. This cathode rays, which is having some interesting properties. The mass of this cathode rays which is very light, because this is 1800 times lighter than the hydrogen. Hydrogen, it has only one proton and one electron. When compared to that hydrogen, this cathode rays is 1800 times lighter, which is a very interesting property about this cathode rays. And this is the production of cathode rays. So using gas discharge tube, we can produce the cathode rays. So in this circuit, we have two terminals. First one is a cathode and another one is an anode. We are supplying some high voltage generator. We are giving some high potential to these two terminals. It will automatically produce the cathode rays. So inside that gas discharge tube, we are filling some argon or mercury vapor, like that, that kind of gases or vapors which is filled inside that gas discharge tube, and we are maintaining some low pressure inside that tube. So we are giving some high potential from this high voltage generator. Automatically the cathode in the cathode terminal, the electrons are generated and it is moved towards that anode. Finally it is end up with a photographic plate. In that time it will produce the fluorescent effect also. And these are the properties of cathode ray. So cathode rays are which is travel in the straight line, and it is a negatively charged, that's why it's called as a stream of electrons. And these cathode rays are deflected by electric field as well as for magnetic field, and it will produce in the cathode terminal and it will move towards the anode terminal. And it does not, that is the cathode rays does not depends on the what kind of gases is filled inside that tube, and what kind of gas is filled, that is not depends on this cathode rays. Cathode rays are the movement of the cathode ray is very slow, and when cathode rays fall on that some object, it will automatically start to heat it, and when it fall on the fluorescent screen, it will produce that fluorescent effect, and it will start to glow, and it has a capability to ionize the gases. And cathode rays are, already we saw that 1800 times lighter than the hydrogen particle. And next one is the anode ray or positive rays. So anode ray is nothing but stream of positive ions which is travel from anode to cathode. And Goldstein, he is the first scientist who discovered this anode rays. And this is again using gas discharge tube, we can produce the anode rays also. Here also we have two terminals, one is cathode and another one is anode. We are giving some high voltage generator, we are generating some high potential between this cathode and anode. In this anode terminal, the stream of ions are produced and it is moved towards that cathode, and finally it will end up with a fluorescent screen, and it will generate some glowness effect in that screen. So using that we can confirm the production of that positive rays. So properties of the positive rays when compared to cathode rays and anode rays, both are having some similarities and also for some differences. This anode rays is also moved towards in straight line path and it will deflected in electric and magnetic field. But in the case of anode rays, that E by M value is changing by what kind of gas is present in that discharge tube. That is a main difference. And it is also having the fall on that some object, it automatically generate the heat, and most of the properties are similar when compared to cathode rays. So these two rays are very important for the research purpose. Using this rays we can analyze various material properties and it will very useful for the research also. In today's session we are seeing about the cathode rays and anode rays and its properties and E by M value of that cathode ray and anode rays. So these two rays are very important in the research purpose because in this world it's fully made up of atoms. So using this rays we are using various spectroscopic tools and we will analyze the various material properties. So these rays are used for research purpose. Thank you.